And I'm not going to put the other wax in for the sake of time and sanity. But trust me, other ones have other wax. So you can see what I was talking about before. Sometimes you don't have to repair a crack in the silicone. So this is close enough that you can't really see the seam. The seam is there. But inside of the mold, this isn't an inflating, this particular crack isn't in an area that inflates. This crack is an area that just needs to communicate some air. And so as long as the two parts are touching, it'll be a functional pipe. There's going to be a little restriction in there, but all in all, the system's going to reach equilibrium and nobody's going to notice. And also, this is a quick and dirty part for the sake of a live demo. Yeah, I tend to be much more anal when I'm actually casting one of these. Especially when it comes to dog hair. Anyway. So that is the mold alignment side. Here is side one blocker. I spray that guy with mold release. Sorry. Only mildly toxic.
Mildly.
So the mold release should dry for a couple of minutes. That's okay. And so the way I do alignment of these two mold halves, I sort of wish that I had a gutter around it like this, because it's very accurate for placing two halves together. What I use for this guy, partially, bigger molds mean bigger printing time, mean more silicone. And so I made the trade-off. Instead of creating a larger mold that could fit that border in it, I made a smaller mold with alignment pins, and they just go together with nuts and bolts.
Is that a different form of silicone than the one you use for the wax mold? Is that the same thing? Is just the colors are just different, or is it?
Colors are different, essentially just different brands of the same idea. Actually, an error that I only found sort of later on in the production, I had accidentally used what's called addition pure silicone and a condensation pure, a tin pure and a platinum pure silicone, against one another, that one was cast into the other. That's a mistake I would not like to make again, because one will cause the other to never cure. So one catalyst inhibits the other. Other things like sulfur will inhibit the cure of silicone. So essentially, this one is, I think, a tin cure, and this one is a platinum cure. The cores touching don't transfer enough for it to cause mold cure inhibition. But originally, I cast them out of this, and you can actually see that this is still slightly sticky because there's some uncured silicone on here, which honestly, I probably shouldn't touch. I'm touching it. Yeah, you should limit your exposure to heavy metals whenever you can, unless it's Pantera. I like using wing nuts for this because I'm always looking for a way to cut down the amount of time I have to spend on this kind of stuff. Actually, when I worked in effects, I had a particular tool. I actually had a friend who built a bunch just for the shop to use. We put together molds with lots and lots of screws and wing nuts. And so what we would do is we would have these things called matrix molds, where the silicone was actually locked into a fiberglass housing. And so you can picture, if I wanted a big mold that for like half of a monster head, I could make the whole thing out of a block of silicone, but that would be tons of silicone. And so instead, we had a shell of silicone and then a shell of fiberglass. And as long as the silicone fit into the fiberglass with little keys, everything stayed in alignment. But it meant that the seam of the fiberglass had lots and lots of screws in it. And so he actually had a tool for grabbing wing nuts and twisting them. So it was a piece of pipe welded onto a piece of hex stock. that we could just put into a drill bit and just hold. Very fun. I possibly, if I have time during the lecture, I will tell you about how I was accidentally adhered to a Cyclops during the monster movie, and the Cyclops was not the monster.
He was just misunderstood.
He was actually just my assistant.
Ah.
I'm not joking.
Mm.
True story. True, not boring story. All right. So now I'm going to show mixing and vacuum degassing and pouring. Oh, more super exciting silicone news. So, would anybody else like to come up and assist? No. This is going to require some gloves. There. So for this one, what we're going to do is measure out 100 grams of silicone, and then mix them up, and then vacuum degas it, and pour it in this guy. And be careful not to get any on your hands. So I actually find easiest to like dig your fingers under there until it pops, and then I think you get it.
He's getting it, got it.
Ruby. I find the hardest thing with these containers. I redesigned these because I've done some engineering for injection molding. I redesigned it and submitted it to Smooth On, the company, just being like, please. Okay, the process is going to be, I'm going to turn it, just a second, so I'm going to turn this on, even though we're doing a little bit of a Potemkin village of a recipe here. Get all the steps right. So, tear the scale. Right, and measure out 50 grams. It's going to be really quick. 138. Okay, so our goal is going to be to measure out 138 of the other side. So the exact amount of silicone isn't as important, although silicone is kind of expensive. Like this is like $100 a gallon. It's not a nightmare. It's mostly the platinum in it. The goal is going to be to measure an equal amount of the other silicone. So this one here, and wipe this off. Everything in my life is sticky. All right, pressure's on. Okay, you see that?
Exactly.
It's fine within 10. It's fine within about 5%. So be close. Really close. So we're looking for 260. No, 270.
76.
Yeah, really quick. Just a little bit. 257. 257. Good enough. This is a process that just takes time to learn. Okay. All right. So the process of mixing this is not counterintuitive, just time consuming. The problem with mixing
as messy as hydraulics, I guess.
It can be messy. So the problem with mixing two clear materials together is you don't really know when they're mixed. And so there's actually a method for mixing silicones, which is pretty much figure 8, then straight down the sides, then dig on the bottoms. And then again, figure 8, straight down the sides, down in the bottom.